Hello, dear student. How are you? How are you? I'm fine. Thank you. I hope you will be fine. So, let's start lecture number 5 of crystal field theory. Today, our lecture of lecture number 5 of crystal field theory. The lecture name is factor affecting delta. Now, today we will study those factor or these factors that affect the crystal field splitting. So, Uh, let's start the lecture. And this lecture, first of all, we should need the nature. We should need to know the nature of central metal atom. Nature of central metal atom or central metal cation. So, if we know central metal cation also have great effect on it is also a great factor that affecting the crystal field splitting that affect the crystal field splitting, like if in case of different charges, if in case of if let's suppose same two central metal ion, same two metal same two metals having having different charges, having different charges, same two metal, same same ligands, same ligand. If the central metal, if there is same ligands and same metals having, but only charges are different, what will be happen in this case? In this case, like here is a two metal, one metal is m plus n, here in this here is one metal, and also same here, same metal is here also. um, those both metal are same. If both have same, if these both are same atom and both have same ligand and both have same ligands, only number of electron or oxidation state of central metal atom only change. So then what will be happen? Means here, let's suppose here is d5, here is d6, means here is the oxidation state would be plus 2, here here will be oxidation state plus 3. So let's suppose if the same metal having same attached with same interaction with same ligand, if only oxidation state or number of electron in d orbital will different, in this case, what would be the factor, what would be the del naught effect, how the del naught will be affect? Here one thing important, one thing is very important, we should always need that oxidation state is directly proportion to oxidation state oxidation state is directly proportion to, directly depend del naught. Means high the oxidation state, high will be crystal field splitting. High the oxidation state, high the oxidation state, high the oxidation state, high will be, high will be del naught. Low the oxidation state, low will be del naught. Means in this case, where here is a d5 system, here is a d6 system, here is plus 3, here is high oxidation state, here is low oxidation state. So here will be high. Let's suppose if there is a 10,000 centimeter inverse, the value of del naught is 10,000 centimeter inverse, let's suppose there it is. So in case of the same ligand and same metal having plus 2 charge, here is, let's suppose here is plus 3 charge and here is plus 2 charge, so it should be less than the above value, because here is oxidation state lower, here is oxidation state, and there is oxidation state greater. So here will be, let's suppose that will be at 1000 centimeter inverse. That means that high the oxidation state, high will be crystal field splitting. Crystal field splitting is directly proportional to oxidation state. So let's do some example. So let's do some example. So let's suppose here is Fe Fe taken H2O, H2O taken 6 plus 2. Here is Fe H2O taken 6 plus 3. In both cases where here is iron has oxidation state plus 2, here iron oxidation state is plus 3. In both cases same the ligand, here be say 6H2O, here be 6H2O, here be one iron, here be will be one, here is the one iron. Only oxidation state or number of electron in both system are different. Here will be, it will be D6 system, it will be D6 system, and it will be D5 system. In both cases here is the D5 system, here is D6 system. Only the oxidation state in both cases are different, but except the oxidation state all things are same. So here what will be the del naught value? Here what will be the del naught value? Here in case of plus 2 oxidation state, here is the del naught value. Experimental value is in case of FeH2O, the crystal field splitting is 10,400 centimeter inverse, while the experimental value in case of plus 3 oxidation state on iron, where the oxidation when the ligand or when the hexa ecosystem. So here will be 30, here is 13,700 centimeter inverse. It is the oxidation, it is the del naught value. So let's see here that high the oxidation state in case of plus 3 on iron in plus 3 charge. So here is 13,700, and in case of plus 2 oxidation state on the central on iron, so here is the 10,400 centimeter inverse. It means that high the oxidation state high will be crystal field splitting. So question is that why oxidation state directly depend upon the crystal field spread, why crystal field splitting directly depend upon oxidation state? Why when the oxidation state is a high oxidation state, why high oxidation state have high del naught value? The reason of this question is that the effect that is this effect is probably due to the fact that the central metal atom, that the central metal atom with high oxidation state, central metal atom with high oxidation state, will polarize large ligand, will polarize will polarize the ligands the ligands effectively, more effectively. High oxidation state will polarize the ligands more effectively, because here is oxidation state, greater oxidation state. Here is the greater oxidation state because when the positive charge on central metal atom is high, here is, let's suppose here is plus 2, here is plus 3. When the both metal are same, the plus 3 charge, let's suppose here is plus 4 charge. So m plus 4, so m plus 4 will be in case of m plus 4, the larger the splitting will be greater than m plus 3 in case of m plus 3 cation, in case of m plus 2 cation, which is be greater than in case of m plus 2 cation. If these metal, if the metal are same, because high oxidation state will polarize the ligand more effectively. If it approaches to ligand, the ligand can approach easily to the central metal atom. Or you can say that in case of high oxidation state, 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 in this case lower will be the electrons in a d system. In the d orbital, the electron will be low when the oxidation state is high. If the electron is, so the another example, the another reason of this question is that that's why crystal field splitting directly depend upon uh, oxidation state. If oxidation state is high oxidation state will have lower d system as compared to the ion or central metal atom that has low oxidation state will have the high electron in d system. So if the in D system has high electron, let's suppose the another example in D system has five, in one case is 5 electron, in the other one case is 6 electron. Here it will be plus 2 charge, here it will be plus 3 charge. Mean high oxidation state will be lower electron system, and lower oxidation state will be high electron system. So if the electron system is high, if there is more electron in the d system, the ligand the ligand itself is negative charge, so the ligand cannot approach to this central metal ion perfectly or effectively, because here in case in d system there is more number of electron, it will show some repulsion, it will show some resistance to the ligand electron. That's why ligand cannot approach easily to the system. So the ligands so the in this case where the oxidation state is lower, so in this case the splitting will be uh, the splitting will be low, while in case of high oxidation state the splitting will be high, because here is electron less number, here is less number of electron. So if the electron number is less, the ligand will show the electron will show less, if less collision or less resistance to the ligands, so that's why ligand can approach easily, and the splitting will be high. This is the reason of the this is the reason of the high oxidation state directly depend upon the directly depend upon del naught. Is that clear? Okay, you can also take screenshot from this lecture. So I'm going to remove, I'm going to clean the board, so you can take screenshot or you can rewind. Okay, thank you. So the central middle line is also depend upon the nature of the crystal filtration also depend upon the nature of the central middle atom. So let's suppose that in another case, if ligands are same, if ligands are same, if ligands are same, d system are same, d system are same, d system are same, oxidation state are same, if the d system, if the ligands are same, oxidation state and d system are same, only only number only mm, central metal atom are different, only central metal atom are different. Then what will be happen here, what will be happen? So here in this case in this case is here here is sorry, here is two different cations, only two different central metal atom having the same number of two different metal cations having the same number of d electrons and the same geometry of complex, same number of d electrons and same geometry, same geometry, also same geometry of the complex, but with only different central metal atom, or but only with different charges, only with different charges on central metal atom, only different charges with central metal atom. The cation that have high oxidation state, the cation that have high oxidation state has a larger value of del naught, has a lower value of del naught, having a low oxidation state, lower value of del naught having low oxidation state, while in case of in high oxidation state the higher will be higher value, higher will be the value of del naught, higher value of del naught will be when the case of plus 3 ions. What will be, for example here, let's suppose that is vanadium, hydrogen 8 2O taken 6 plus 2 ion is equal to here is chromium H2O 6 plus 3 system. Let's here is vanadium has plus 2 charge and chromium has plus 3 charge, while the oxidation state of in first case the oxidation state is plus 2, and in the second case plus 3. Here in both cases, here is also the D3 system, and here is also D3 system. The D system are same, the ligand are same, only the center metal atom are different. When the center metal atom are different, and also the number of electron in D system are same, the oxidation state should be different. So in this case, the high the oxidation state will have high del naught value. Experimentally, the del naught for chromium 8206 is 17,400 centimeter in Earth, while in case of vanadium plus 2, in case of 820, when 806 820 are in interaction with the vanadium, the crystal field splitting value, experimental value is of 12,400 centimeter inverse. 12,400 centimeter inverse. So see, here we see that, here we saw that, say in case of high oxidation state will have high value of del naught. Del naught crystal field will be larger, splitting will occur. In vanadium, crystal field splitting will be lower, while in case of chromium, crystal field splitting will be higher, because here is the, in case of chromium high the oxidation state, while in case of vanadium lower the oxidation state. This is the main reason. And I all the in the previous in the previous part, I already explained you that why the oxidation state, how oxidation state depend upon the value of del naught. Okay, is it right? Mean the, it means that the chromium plus ion, the chromium plus 3 ion, which has greater positive charge, then vanadium plus 2 ion exert a greater attraction for water molecule, while it has plus 2 charge, so it will less attraction, it will show less attraction for water molecule. So that's why in this case, in chromium case, the ligand will approach here to the central atom effectively, so the system will split largely, while in case of vanadium the system will split very low. So is it clear? Okay, this is the nature of central metal atom, having different central metal atom, but all the properties are same, only central metal atom are different. So then this will be happened that I explained. Here what will be happen when there is, when the case same charges on central metal atom, two different two different central metal atom having same charges, same ligands are attached with these same ligand in the complex, but only number of electron in the orbital is different. So what will be happen in this case? In this case, in this case, let's suppose here is let I explain to example. Here is COH2O6 taken 6 plus 2 charge. Here is a nickel H2O6 plus 2 charge. Here is a cobalt is also plus 2 charge, while nickel is also plus 2 charge, while here is only here is in cobalt, here is 3d7 system, 3d7 system, while in case of nickel there is, here is 3d8 system. So only the number of ligand also same, oxidation state is of both metal atom is also same, only number of electron in this system are different. What is the reason, what will be cause, what will be effect? Here the experimental value for this complex, the experimental value of del naught for this complex is 9,300 centimeter inverse, while in this case for nickel, in this case in this complex, the experimental value for the splitting, del naught splitting is 8,500 centimeter inverse. This is the experimental value. So here let see that the oxidation state high the number of electron in 3d system, high the electron in d system, high the electron in valence shell, lower will be the crystal field splitting. Means larger the number of electrons in a d system, d orbit, d orbit, lower will be lower will be the del naught value. Means it is inverse, del naught is inversely proportional to the larger to the number of electron in d orbital system. So larger the number of d electrons, lower will be lower will be del naught. Lower the lower the electron number, lower the electron number, higher will be higher will be del naught, as you see that here, as you see that here. So what is the reason for that here? Sorry, here is also the same reason. What is the reason? Lower high the number of electron in d system, in this case it will show high resistance to the coming ligand that approaches, that are coming to that are coming or approaching to the central metal atom, that show that show resistance to the system. So that's why the ligand cannot effectively interact with the central metal atom, or ligand cannot be effectively approached to the central metal atom. While in case of where is the electron low, here is the low electron system, are less electron. So in less electron, here will be less entry, less here is less repulsion, show less resistance will show to the coming ligand. So that's why ligand can approach effectively to this central metal atom. That's why the crystal field splitting will be high as compared to the system that have high number of electrons. Is that clear? Simple reason. Okay, you can also take screenshot from this lecture, from this topic. Now I'm removing this. I am cleaning the whiteboard, so you can take screenshot or you can rewind the video. Okay, thank you. So here we start the fourth point of del naught factor affecting the del naught. So in this case we studied we'll be study the quantum number that is like KLMNOP, or that is the quantum number of shell. The quantum number, how the quantum number affect the d orbital of central metal atom. Larger the quantum number value, larger the quantum number value, larger the larger the quantum number value, n value, high will be splitting, high will be splitting. Lower will be lower the larger lower the n value, or lower the quantum number value, lower will be lower will be the splitting, lower will be the del naught splitting. It means that the oxidation state n is directly proportional to the del naught. Means high the value of n, high will be del naught. High means high the value of high, the more the quantum number, more will be the del naught value. So what is the reason behind this? Let's first doing some example. So here in, like the example is cobalt in a 3, cobalt in a 3 taken 6 is equal to 2003. Here the experimental value, here is a plus 3 charge. Here the experimental value for this system is for del naught is 23,000 centimeter inverse. But this is the system 3D6 system. While in case of RH RH in a 3 system, in a 3 6 system, there is also plus 3 charge. So here for this oxidation state, for this complex, the experimental value of del naught is 34,000 centimeter inverse, but it is the case of 4d6 system. While for 5d system, IR NH3 6 plus 3 ion is equal to, here the experimental value for del naught and for this complex is a 41,000 centimeter inverse. So there here is 5d6 system. So you can see that you can you can see that larger the greater the value of more the value of quantum number, more will be the splitting. So what is the reason behind this? The reason behind this is larger the quantum number, larger the quantum, let's suppose this is the nucleus, the centimeter atom that has first shell, second shell, third shell, fourth shell, fifth shell. So that is the 3D shell, that is 4D shell, let's suppose that is 5D shell. So I can say that the 5D shell is most exposed shell, more it is more exposed, it is more exposed to the central metal, it is more exposed to the ligand, it is more exposed to the ligands, so the ligand can approach to this system, the ligand can approach to this orbital is effectively, while in case of 4D system it is not so much exposed like 5D system. So but it is much exposed as compared to the 3D system, so that's why we can say that 5D is more exposed than 4D, while 4D is more exposed than 3D. So that's why we can say that the ligand interaction with 5D will be greater, will 5D system will be greater, which is the ligand interaction will as compared to 4D, while 4D interaction with ligand will be greater as compared to 3D. So that's why when the interaction is greater will be splitting. So we can say that 5D system will have larger splitting, del not splitting, while the 4D system has not enough splitting like 5D, but for 4D system splitting will be more larger than 3D system, because 4D is more most exposed as compared to 3D system. So this is the reason, and this is the topics, this is the topic that end of the topic, today topic, lecture number 5. And lecture number 5, what is the lecture number 5? Factor affecting will not, how it will not affect by different factors. We already told you, I already explained you. So um, I hope you will be clear, you will be get easily. Okay, thank you very much. Be read and be careful, be studying. Thank you. Goodbye, best of luck. Also share this video with your classmate, with your friends, with your chemistry friend, so that they can also take help from the video, from they also understand the topics. Also please subscribe my channel, support me, to make me feel that you support me. Okay, thank you very much, best of luck.